Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We are going to be doing some work with lighting today. We kind of got to a place where the lighting bounces were actually working pretty well last time. But I think today what we probably want to start looking at a little more seriously, because I think it's probably our biggest problem at the moment, is how we're going to correctly deal with the reconstruction of the lighting from the samples that we have. Because that's actually something that right now we don't have a very good handle on. Furthermore, I think the other thing that we probably want to do, and we might do this first because it's a little more straightforward, is now that we pretty much know how we want things to work, we might want to do something where our render system allows you to send down two things. One, occluders that are blocking light, and we can send those down separately. So we can basically say, like, okay, not everything, like, for example, sprites are not occluders. Cubes are occluders. Sprites will have a separate thing sent down with them, let's say, which says what the shape of the occluder is or how the occluder works. So that we won't excuse me, so that we won't actually have to worry about that. Stuff like the incredibly weird bent, sprites for so that things that still face the camera are drawn properly, so that those themselves aren't what's blocking the light. There's actually like a little invisible cube or something in there that is what's blocking the light, so that the shadowing can work more correctly, even though the drawing is not done quite that way. So that's one thing. The other thing that we can choose to do there is think a little bit about how we want to specify the sampling area as well. So, for example, right now we always sample things based entirely on the occluders themselves, but we don't have to do that, right? We can choose our gather points separately from exactly where our occluders happen to be if we wanted to. There's nothing really stopping us from doing that. So we kind of have to do some thinking about how that sort of thing wants to work. And there's a lot of different ways that we can do it. And so that's, I think, the next thing that we have to experiment with in order to converge towards a better lighting solution. Because we sort of have a good way to bounce light around now, and while we will refine that a little bit in the future, I think what's holding us back at the moment has more to do with specifying and reconstructing the lighting samples than it does with computing the actual lighting, which is something that I think is not quite as problematic at the moment. So let me just give you a little example of what I'm talking about. If I go ahead here and load up our current state of the game. So here's that project file. Slide this back a little bit. If I go ahead and build the current project file, what you will notice is that at the top of the platform file, we do have a thing which just is like a hard-coded lighting resolution. And what we can do in the future is, this doesn't have to be hard-coded. We could easily just allocate space for these dynamically so that you could switch the resolution of the lighting on the fly. So we just have it hard-coded for now because that was the easier thing to do at the time. There's nothing magic about it that means it has to be hard-coded, so that's not really a concern. But what you'll notice is if I change it to large cells, so this is 8 by 8 by 8 voxels, so the cells are twice as large in every dimension as, say, the 16 by 16 one was, right? So if I run the game with that as the arrangement and I ask for a lighting solution, what you can see is that the lighting solution actually looks pretty reasonable. And when I switch back, I actually get something that's probably usable. Now, there's some things with it that still probably should be improved. So I'm not trying to suggest that it's great or anything. But it's definitely a lighting solution that, could be considered usable already, even in its current state. So, you know, because remember, these will all have bitmaps on them eventually too, so we're looking at kind of pure lighting right now, whereas in the future, it will be even noisier because of the bitmap information that's on there, so it'll be less hard. It will be much harder for you to tell that there are certain bugs in the lighting interpolation or things like that, right? Okay. So looking at this, that's actually not a bad lighting solution. Like, I'm actually okay with that, and I wouldn't be like, you know, super worried about this as my lighting solution. This is fine. However, if I am now to change my lighting solution over to 16 by 16 by 16, oops, which is a more detailed lighting solution. So this is actually like a better lighting solution, if you will, right? In a way. It's basically keeping more accurate track of where things were sorting wise. I mean, it's not really more accurate, but it's like, how should I put it? It's the voxels are now are smaller, so when you ask for what's in one, you only get stuff that's closer to you than before, right? But what you see is it starts to ruin the lighting, right? And the reason is because you get too many voxel samples, and there's places in the voxel where just we didn't take a lighting sample at all, and so the interpolation starts to break down. Or there's some bugs in it. Like, we don't really know, but this would be perfectly explicable by what I just said. And that's bad, because we would like to be able to run the voxel at a fairly reasonable discretization level, because the bigger the voxel, the bigger the voxel region is, the slower our lighting runs. If the voxels are very large, then each pixel, when it goes to fetch all of the lights it needs to consider, is going to be fetching way more information that it has to sift through, and that is what will cost the majority of our time, right? So we want to be able to make these voxels actually very small if we wanted to. A 32 by 32 by 32 voxel. Oh, we installed something for this calculator thing, didn't we? Speed Crunch, people were telling me to try. Maybe I should try this program. I will pin it to the taskbar. It was recommended on stream. So if I do 32 times 32 times 32, then that is the number of cells in our voxel, right? If I assume that each voxel is using something on the order of a U16, right? Then it's really only times 2, that's only 64K, right? So, you know, we can have a very detailed voxel here, right? Like, even a voxel that was 64 by 64 by 64 is only going to be half a megabyte. I mean, we could go up probably, I don't even know how far we could go here, but we could go pretty far. That is only 32 megabytes, right? So, you know, we could choose to have an extremely detailed voxel here, like so, and not really be using very much graphics card memory compared to what you have today. And that would allow our lighting to be like really fast, right? But the problem is, if we actually look at what will occur when we see this result, you can see where the lighting samples are taken now quite clearly, right? And there's just not enough information in each voxel area, right? So when it goes to interpolate between them, you know, the next voxel area is like right there, right? And so the problem that we see now, that we need to figure out a way to start working away from, is that voxel queries aren't necessarily what we want in all cases, because while they're really efficient at telling us what's next to us, they're not so efficient at telling us what the closest things to us are, right? Because that's actually what we want to know. We want some... let me go ahead and pop over to Milton, actually, just so I can describe this in a little bit better detail. There we go. I'm going to grab the drawing tablet here for a second, just so I can illustrate something. So let's say I go ahead and open up Milton here and draw a little picture of this. Day 415. So, voxel interpolation of lighting. That handwriting. It's the majesty of it. So the problem that we face here, and I can just do the 2D version because it's easier to visualize, but the 3D version just gets worse because now you have one more dimension in which the same thing is true. You can imagine what happens for this problem. We have some lighting, like so, right? Each of these lighting locations will have an actual valid value of lighting at it. And so, if we are to pick some point, let's say here, the question we are trying to ask of our system is, I would like to know what the close sample points are so that I may mix them together and produce a reasonable lighting result for my location, right? That's what I'm trying to do. So in the case where the voxel areas are large, let's say that this whole thing is fixed in one voxel, right? Then this is no problem, because not only am I going to light by these voxels, I'm also going to slowly blend to the lighting of this next voxel over as I move in this direction. So as I move this point over this way, I'm going to be including more and more weight from samples over here. So not really a big deal, and we get some reasonable results out of it, right? However, what we don't have is anything that allows us to solve the situation where it looks more like this. Let's say the voxels are only that big now. Well now, hey, I know really definitively when I ask for what's nearby me, I know that nothing is immediately nearby me. But that's not really what I want to know. I wanted to know if I had to go get a lighting sample, where would I get it from, right? I need lighting samples. I can't, the answer, there are no lighting samples next to you, while accurate, is not useful, right? I need to know about these lighting samples, and I need to get enough of them so that I can actually do some work, right? And so that's the current problem that we face when dealing with this voxelization situation, is we're not really doing a good enough job here of representing a query that gives us back the lighting samples that are nearby. And it's unclear how to really do that. This is a classic reconstruction problem. It would be great if I was an expert in reconstruction problems. I'm not. So that does put us at a bit of a disadvantage, but whether we're at a disadvantage or not, we're going to have to solve it. So thinking through in my head some information about this, what I'm kind of thinking is, you know, if you had a spatial query, one thing you might want to do is have this query be somewhat adaptive based on the density of lighting samples in a region, right? I mean, that's another way we could sort of think about it a little bit better, right? So let's say, for example, you were putting lighting samples into something, right? You could imagine an alternate style of system that basically said, well, once I get too many lighting samples in an area, then like I split the area, right? So once, you know, I get too many, I split it in half or something, right? And then I keep adding them, and once I get too many of those, I split that in half, right? And I keep adding, and then I split that one in half or something. And then I keep adding, right? And so on. So if the lighting locations were done on CPU side, that doesn't seem like a bad idea necessarily. It's hard to say. But you could imagine doing something like constructing a KD tree where now you would basically say, well, we break the world into buckets, and the buckets all have a reasonable number of lighting samples. So when you query your location, you will get a bucket back that has like 4 lighting samples because there are no buckets that don't have 4 lighting samples or more, right? And that seems somewhat useful to solving the first problem, which is not enough lighting samples in my region, right? So we could imagine constructing a data structure that was a little bit different than a voxel, although still quite simple, and it would have that property to it, right? The problem with that is if we do want to do that construction of the location of the lighting samples on the GPU, that could be harder. If we do it on the CPU side, it's not. Because the CPU side has random access to memory, can do anything it really wants to, doesn't necessarily have to be parallelized to be fast, depending on how many of these we're talking about and so on. So you could see this being something that maybe it's possible to do every frame or every 2 frames. You know, we can update our lighting sample points more slowly if we have to, for example. So, you know, you could see this being something that is plausible to do on the CPU side and send down, and then we could use whatever structure we wanted because we can always bake that structure into a texture, and then the GPU is just fine at using a data structure like this. It's just harder for it to build it. And you can do it, but usually you end up with wanting to do things like use CUDA or something or a compute shader. You typically don't want to be doing this sort of thing in a non-random access fashion. But it is done. It's not completely out of the question. So that's one thing I'm thinking of. And like I said, the downside to it there is that with a voxel, you kind of have a nicer situation of, well, with a voxel, if you do want to keep a linked list per voxel like we're doing now, then you do need atomics in the shader. So you do need to be able to keep a linked list, which requires a shader atomic. But that's really the only thing you need, right? You don't actually need any random writes or anything like that. You just need the ability to access that one atomic. So I guess what I would say is, you know, there's that as an approach. I like the sound of that approach because I think it offers a couple different things. First of all, it allows us to get access to more points initially with our first query. So I like that part. And the other thing that I like about that is I like the fact that it will also subdivide regions which are overpopulated, even if they're already pretty small. So with our voxel, for example, once we set a voxel dimension, if we started having lots of sample points in one area, now I don't think that's likely, but let's say we did, we could now, with a system like this, it could get subdivided further. So it puts the detail where the detail is needed, rather than just presuming a sort of a known thing up front. So that's all good stuff about it. But I think there's bad things about it too, which means I'm not really excited to jump at it quite yet. One is, again, the complexity of building one of these, while not too bad, is much more than a voxel. It's still a big step up from voxel in terms of the complexity necessary to build one. So that makes it less likely to work on the GPU. It makes it more expensive even if it's on the CPU, probably, right? So that's one downside, is the expense of building. The other downside that's relative to performance is the expense of computation. That's probably the wrong way to say that. Let's say expense of lookup. So one nice thing about the voxel is it's immediate, right? I take a set of coordinates, I truncate those coordinates to a voxel cell, and now I'm going. I'm off, right? That doesn't work anymore once you have a variable space partition like this one, because at that point, what you have to do is traverse from like a root node down, right? You have to start at, the whole thing, go, where is my point on this classifier? Oh, it's on like this side of it. Okay. Where is my point on this classifier? Oh, it's on this side of it. Whereas my point on this classifier, oh, it's on this side of it. Okay, this is my region, right? So each one of our pixel lookups now has this much more expensive traversal scheme involved, right? And that, to me, sounds bad for obvious reasons. So the third thing is the boundary problem. And that is that while this would fix the empty cell problem, right? Voxels have the empty cell problem. And they also have the boundary problem. It would fix the empty cell problem, but the boundary problem remains. And what's that problem? Well, in either case, if I am here and I see this sample, here's a lighting sample, right? So here's some lighting samples. Ideally, what I would like to do right here is I'd like to interpolate between here and here, possibly even a little bit of here, hard to say, right? But I don't really have a way of doing that. Because in order to look at the samples in here, I have to compute the lighting for my cell and the cell next to me, right? And the problem that we get there is then you end up with the fall-off functions for reconstruction now have problems where the voxel boundary, right, causes them to snap in or out of consideration. Because this one here, right, would not be considered, right? But this one would. As it moves towards this boundary, you end up in a situation where the consideration region falls out of where this possibly would be. And then when you get into this region right across the border, maybe one of these guys pops in. You end up in this situation where you have to be really careful about how you set up your reconstruction because you can't have things pop across voxel boundaries, right? Lighting has to be continuous. Otherwise, a pixel right here and a pixel right here will get two different results, completely different results, and you'll see a seam running along the voxel boundary. So what we're really trying to avoid here is that problem of seams that show up because of the spatial partition. And in order to get rid of those, we need something in either case. Because even if we say that we pre-divided everything down, right? So that we always have, 4 samples per region or something close to it, then we know we're never in a case where we're sampling a region that's empty. But we don't know if, for example, we're sampling a region where there was a lighting sample right here that we should have been taking into account, and we're not taking into account, and when we move over here, we are starting to take it into account, right? So the boundary problem kind of remains. Luckily, to a certain extent, we were doing interpolation between fixed points in space in our voxel case, and that's how we got around that. We would just say, well, we always blend between the 8 voxels that are all in the area, right? But again, even that's kind of ugly because that means we're doing 8 times as much work for only one reason, and that is to prevent that overlap, that snapping problem, those like seams, right? So the reconstruction problem is like really hard for all of these reasons, right? And you want to find something. I mean, your ideal thing is something that is continuous everywhere. Because that means no visible seams. has nice accuracy, like uses samples well, and low overhead, right? Not too many samples considered. And there's some aspects of this. So continuous everywhere, no visible seams is kind of the one we were talking about how you make sure that, as because you're not considering all 8,000 samples every pixel, how do you make sure that the subset of samples that you consider doesn't lead to seams? That's one problem we got to deal with. The nice accuracy one we haven't talked about too much, but, let's say we've got a place in the world where there is a seam that's really supposed to be there, right? So there's a lighting at a corner or something like this, right? And, it's dark here, it's light here, it's light here maybe, right? And dark here or something. We want to, as much as possible, to try and reconstruct the fact that, if there's a bunch of dark samples here and a bunch of light samples here, that the lighting should change pretty rapidly in between those two, and we should have a dark side and a light side, right? We really don't want something where, like, the light side bleeds way over here or the dark side bleeds way over here or whatever, right? So if we do a good job placing our initial samples in the world to capture the lighting features we care about, which we probably can do because we know what the scene looks like, so we can probably place samples fairly intelligently, we want those samples then to make sense. When you reconstruct them, we want them to to produce good results based on the information that was presented, right? So yeah. So one thing that I am thinking about as well is I wonder if we need to think about this problem in a slightly different fashion too. So one way of looking at this problem is that we have an unordered set of samples and we're trying to reconstruct from those samples, right? But another way to look at this problem would be that we're actually just going to take lighting samples and we're going to use those lighting samples directly, right? That is one way we could look at this problem. And it might be that we have so few lighting samples that we actually care about that would work. And I realize that what I'm saying is a little bit strange at the moment. So let me explain. But what I mean is, well, we're looking at this problem like I've got a cube. And so when I send this down, I know that I'm going to produce like some occluders or whatever, right? Or something like this. Yeah. And then I do some stuff and then I draw this polygon and I go sample and I look to see where I've got my various lighting samples. Right? And this is what leads to the reconstruction problem because I need to look out into the world and find what samples are relevant to where I am. Now this has a nice benefit of if we were to have lots of things in this area, they could possibly pull from lots of lighting. However, we could alternately say, we don't want to bother with that. Instead, what we'll do is we'll just say that a cube gets some lighting samples on it, and it just uses exactly those lighting samples to interpolate, period. Right? Like, it doesn't do anything else. So when you are actually drawing one of these, you just always have each quad that you draw, let's say, just has its lighting samples prescribed, and it just uses those 4 lighting samples. End of story. Right? So we could do something like that, where we basically say these are our lighting samples and we pre-say which lighting samples you're interpolating between. There's no voxel involved. Those lighting samples, the occluders and the lighting samples all go into the lighting solution, but the results of the lighting samples are only sampled by the people who actually wanted those lighting samples specifically, and there's a one-to-one correspondence between the two. No spatial partition at all. Right? So looking here, this is our scene broken down in this way, kind of already. You can kind of see if we looked at this, right? If we were just to say, look, forget it. We don't want to do the reconstruction problem. We're not going to bother with that. No more voxel. It's just a waste of our time. This is the chunking of the scene that we'll use, and we'll just render it on these borders. Right? Now we can even go one step further and say it doesn't have to be regular. Because one of the things that we'll run into problems with any regular sampling scheme is you will see the sampling scheme, right? But we could say, no, forget it. We don't even want to do that. We want to be saucier gentlemen. We're going to be even saucier, right? What we want to do instead is say, look, here's a plate, and here's where we put the lighting samples. So they're just going to still do the splat, right, with some radial interpolation. So it's really hard for you to see where the seam is, because it's not this regular thing where you can see the seam is like running like right like that. Because we can still do a thing where instead of the plate being, instead of tying it to the vertices, we can instead just tie it to points. And when you draw this surface, sample these 8 sample points or whatever, right? And as I'm saying this out loud, I've never considered something like this before. It just sounds like a really good idea. Now, maybe that's famous last words, but this to me seems a lot more sane because the reconstruction problem goes away, right? Because now you can reconstruct your points however you want because you're always using the same points on this surface. So this flat, because everything in our game is a flat surface with a bitmap mapped on it, right? So everything across that entire surface will be lit by the same n sample points. So any arbitrary reconstruction scheme you use will be continuous as long as the actual addition is not itself discontinuous, which is really easy to avoid. There are no sampling boundaries because that shape never crosses any boundary, right? 2, it's faster because now you don't have to look up in voxels or anything else. You just, every polygon comes down with an ID. It looks up that ID and that gets it the linked list of samples to use, right? And it just goes through them. So it's the same scheme we have now, but instead of first looking into a voxel to find that first U16, forget that lookup. Just pass down the U16 that you wanted to use directly. Problem solved, right? I mean, I think that may be the winner. Because then all we really have to do is come up with a good way of scattering points across our geometries, right? Of where we want to take those lighting samples. And then we're pretty much done. We don't have to create a spatial hierarchy or transmit it. All we have to do is pre-scatter those points and make sure that then the GPU has that array of points. And I think that's it. We still have the trouble of we have to move the ray tracer over to the GPU at some point, but we knew we were going to have to do that regardless because that's how we're generating our lighting solution. So I think this may be the thing I want to try. I can't think of a lot of reasons not to. So I think I'm going to do that. That seems like the best approach. All right. This thing is kind of fun. Well, anyway. It's not as artificially as intelligent as some calculators maybe, but I mean, it's no wool from alpha. Anyway, so if we were going to do that, then we wouldn't need this voxel here at all, right? I'll leave it in place in case we decide we need it later. I won't delete it till we're sure this is working the way we want. Yeah. So everything else can stay the same. The C and D values we can leave because we do still want a light lookup table that is a linked list. So that part should remain roughly the same. What we do need to change is when we're actually sending these down, we've got these textured vertices here. Those are going to go into this push buffer and all that. And so we've got these quad bitmaps, texture vertex array situation, right? And what this is this is just a big array that says what bitmaps to use and what the vertices are. So there's 4 vertices per bitmap and so on, right? So what we want to do here is we want to augment this structure. Right now, what we pass the GPU is just this textured vertex, this big textured vertex array. What we want to do in addition to that now is we're going to want to pass a U16, which is like a lighting sample index, right? Something like this. So it's basically every quad will have a light sample that gets handed down with it, and that light sample is, you know, the thing that it needs to work with, right? And to be honest, I'm not 100% sure I think somehow I've never done something which gets streamed into the pixel shader that way. So it may be an interesting, it may be kind of an interesting thing to see how we do that, because I don't think I've ever tried it before. It should work, but... Setting up an array that's per primitive is not the same as setting up an array that's per vertex. Most things are done per vertex, and so I don't really remember or know. I think you have to set something up with the strides to make it work properly. It's going to be odd, right? But what I mean to say is, so in here, when we're sending down primitives, right, we've got stuff like here where we've got these in vert P, vert N, vert UV, vert color, right? Those are all inputs to the vertex shader that happen one per vertex and are transformed. What we want to do here is we want to have ins like down here in the fragment shader, but we want them to be per primitive, right? So every triangle, actually every quad, but OpenGL doesn't really deal with quads. Every triangle wants to have a U16 input that doesn't vary over the face of the triangle and that only came from one point in the in an array. Now, we can cheese this if we needed to by just replicating the U16 multiple times, right? We could just write the U16 3 times or 4 times, like 1 per vertex, right? In other words, up here in this textured vertex thing, we could just have like a U16 that was in here or something like this. And that would say, like, here's the light value to get or whatever, right? And we would just replicate it or just use the first one. But at the moment, that doesn't seem like a particularly good idea. I don't know. Maybe it would be good for now. In fact, maybe that's the easier way to do it for now instead of moving it out to a separate thing. Because since we're just doing this for testing, yeah, I mean, I could see that being a good idea. So maybe I'll do that for now. So right now we've got textured vertex emission, color P and UV, right? And what we would be doing here is saying, well, we're going to add something to the end of this. And at the moment, there's what, like 10 floats in this thing or something like this, 10 32-bit values, right? That's 9 right there, 10, it's actually, is it 11? Is that right? So here's 4. Well, you know what? Check this out. Now that I've got this speed crunch thing, 4 plus 3 plus 2 plus 1 plus 1. So I guess maybe it wouldn't be the worst thing in the world to get off of 11 as a stride, but even so, we don't really need it to be in here is my point. And emission, I guess, probably doesn't really need to be in here anymore either. But that's a separate issue. Maybe it still does, we'll see. And I suppose what we could do there even is just say like, okay, there's a light offset, and it could even be a 32-bit value if we want it to be, because at this point, we don't have the problem of needing to really use linked lists so much anyway. We can just point directly into an array and have like a 0 terminator. So you just go till you get a 0 or something like this. Or you could even go, we could even do something like this. Use a 16-bit offset and a count. So that the count basically just says how many to read, right? We could do a lot of stuff like that. So we have a lot of ways of playing with this. But for now, I'm going to stick it in here, and I'm going to put a to-do on it because, like I said, we don't need it per vertex. So when we're ready, when we're in the mood to like get into another protracted fight with OpenGL about some basic stuff, switching to sending that down in a separate buffer that gets read per vertex, I'm sorry, per primitive would be good. The reason I don't want to do that right now is because I'm imagining it will be a complete mess to do so. It might even require us to do like a geometry shader or something that replicates. For all I know, there may not be a built-in way to actually set that up. Which is stupid, but that may be the case. You never know with graphics stuff. Graphics APIs are almost universally lousy. So what we need to do is just have some way for the moment to sort of hack it in there. And then once we have it working in the hacked way, then we will figure out how to sort of play with it further. All right. So if we were going to do that, then what we need to do here is extend our notion in the ZBias program of what comes in. So here you can see the things that were coming in, P, N, UV, and color. Emission wasn't getting read in this one, and that's because we didn't actually use it for anything. But the rest of the things were. So if we have a light offset and a light count, we want to read those values in. And those are integer values, but don't actually know whether it will allow us to specify an integer as an integer in the vertex data. I'm not 100% sure whether it allows that or not. In our voxel, how we used to do that here in this thing, we did use to sample the texture that way, but I don't know. So we can sample, we were able to sample texture integers. I just don't know whether we're allowed to sample vertex buffer integers. I'm assuming we will, so I'll try that first, but we'll find out in a second, I'm sure, right? So if we do an in here, this is going to be a short, right? And I don't know whether we can do an unsigned short here or not, but that's what I'm going to try. And really all I want to do right now is just see whether or not these work, right? That's it. That's all I want to try and do. So I'm going to go ahead and say these are both ins. I'm just going to run the program now and see whether that shader compiles. That's all I want to do at first, right? So it looks like it at least compiles. That's good news. So now what I need to do is go, all right, if we have these things getting put in, I also need them to be put out as well, right? Now, normally we type this. Right? You can see up here we've done smooth out, smooth out, smooth out. Now, smooth, what that actually means is perspectively correct interpolated across the triangle. That's what that means. We don't want that, right? This is just a hack to get this in there. So all we actually want to do is just pass it straight through. So if we take a look at the OpenGL GLSL quick reference, we should be able to where is our GLSL? That's not it. These are not GLSL. There it is. So the things that we can specify in terms of how we want things interpolated hopefully are listed on here. Of course, the fact that I don't see that listed anywhere here doesn't fill me with confidence. Am I missing it? Or did they just not put it on here? We may have to go to the actual spec, because I don't see it. I might just be missing it though. Here, okay, there it is, there it is. I blew right by it. So here's the part we're talking about, which are qualifiers. And specifically, we're talking about interpolation qualifiers. And as you can see here, what I just said is listed at the top. Smooth is perspective correct interpolation, right? What we actually want, if you wanted some weird sauciness, you could do no perspective interpolation, right? And that would give you linear. That would give you the old effects of the PlayStation 1, if you wanted. Right? So you could have some fun with that. Flat, though, is what we're actually looking for. We want it to not touch our values at all, because we don't have multiple of them to interpolate in the first place. So just to avoid any wackiness with the interpolation, we're just going to say, look, what I output, leave exactly the same, right? Don't interpolate at all. Now, the problem with this is I don't actually know if I can, like I said, if I can actually get this into the pixel shader itself and not have to put it in here. So that's why I'm doing this compilation test to see. Okay, so that suggests... wait, what? Oh. Okay. So I assume, and I don't really know, but I assume that I have to output this to the, like I have to actually send this down to the pixel shader. What I would have liked to have done, right, is just said that this comes directly in the pixel shader, but I just don't know if that's actually possible, right? That's what I'm trying to guess, really. I know exactly what I want the GPU to do, but I don't really know how to make it do it, which is generally the case with GPUs. So these are going to be flat ins here, right? Like so. And in theory, this should link now. Yeah. Now, what I don't really understand is what no interpolation really means in this case, because if we are talking about something that's declared both in the vertex shader and in the fragment shader as not having any interpolation, then which vertex does it take? Presumably it takes the one from the first vertex, but I don't know. It doesn't matter because we'll just send the same one down all the time, but either way. So in here where we've got this flat in unsigned short, right? These are now our light offsets and our light counts. And what we can do now is in our sum voxel light routine, right? We can leave that in there again. We'll delete it later when we're sure we don't need it anymore. But what I can do is say, okay, let me cut and paste that a second time and just have a sum light routine. And that sum light routine will do the light summation for us without having to do any of the voxel stuff. So this light I here thing, that's just going to take this frag light offset directly. And it's going to start at that. And it's going to count down the light, or I guess I could count up the frag light count. And it's just going to sample into the texture based directly on that, right? So what we want to do is something like this. So we grab a count of the lights that we're going to use. We grab the first one, and then each time through, we just loop through, right? I don't know enough about GPUs to know what the fastest way to do loops like that is. That's probably something we would want to look up eventually if this turns out to be the thing that we do. But for now, it will work, which is all we really want. We just want a way to test it, right? So while there is lights left, we just keep going, and that's really it. We do the summation exactly the way that we were doing it before, and off we go. Then in here, instead of doing the sum voxel light thing, we just say, okay, that's gone. We're not going to do it anymore. Instead of all of this stuff, we're just going to do a V3L, and actually literally all of this stuff. We're just going to do a V3L. That's, what are we calling this? Just some light. And that's it, right? So all we need to do is just now sum the lights that we've been told this primitive cares about. And they can be whatever, we don't care what they are. We're going to use them, right? And then we output a final interpolated value, and we're done. Right? That's it. End of story. So one nice bonus of this is this will be way faster, right? This is a way more efficient way of doing the lighting than we were doing before. The question is just, will it work? And we don't know. But we're going to try. Okay. So now we just have to get this compiling so that we can get somewhere to start from. Implicit cast from medium p uint to int. Is that so? Tell me, pray tell, when I... Oh, right here. It's like, where did I do that? And it's like, right on that line, actually. Implicit cast from int to bool. Okay. While light count is greater than 0. Are you happy now, compiler? Okay. So now, and we're still working just fine too. You'll notice we don't get any light because, of course, we're not actually passing any values down there. So the light count will always be 0. But we're running under that shader now. So now our job is just to actually pass down some light information that actually correctly lines up with these surfaces, right? So the first thing that I want to do is I want to cheese out, right? That's the most important thing to do is to cheese out first, using, of course, what I always say, structured art. Concept of structured art first introduced to me actually by Mike Biddlecombe. He was a programmer from it was a company that I can't remember. Was it Distinctive Software? No, I can't remember the name of the company because it had gone away and got merged into another company by the time I met him. But it was a company that did hockey games, and I think they got absorbed by EA or something eventually. I can't quite remember. But anyway, he was the first person who used the term structured art that I had heard. And it's like the greatest technique, right? Like, it's always a good thing to drill into your head. Like, whenever you're going to do something new, whose only real way of verifying what it's doing is by visually looking at it, instead of trying the real solution first, do a fake one first that outputs very obvious values. And if you don't see those values, you know you have a bug before you even got to the full part of it, right? So structured out, sending down solids, reds, greens, and blues in various patterns, like that sort of thing. Checkerboards, blah, blah, blah. Very important, right? It's how you can see more clearly when you have bugs, because a lot of graphic stuff is very subtle. You might think that you've gotten something working, but you really don't. Or you may have stuff that's so hard to tell what you know it's wrong, but you can't tell why. Structured art can help reveal those patterns to you so that you can more quickly zero in on what you actually have to fix and what's wrong, right? So what I want to do is I want to start with some structured art. I want to try to figure out a way to start by sending down, let's say, red, green, blue, white, as four lighting samples on the corner of every quad. So that way, every quad we look at should have a red corner, a green corner, a blue corner, and a white corner, and a wash in between as it interpolates between those samples, right? That's what we want. Okay. So let's figure out a way to do that. Let's go ahead into our render group here, and we need to start thinking about how this is going to work. This is going to get more complicated. Our render group's going to have to get smarter over time, but at the moment, we can do something relatively straightforward. When we go to push a quad down the pipe, like so, what we can do in that push quad is we can then use that push quad to reserve the texture room that we needed, right? So here is the funnel through which everything in our game goes. You can see it like right here. So what I'm going to say is I'm just going to start with the stupidest possible thing. I'm going to say, all right, vert 0 gets a light index and a light color. And I'm going to replicate it to all vertices. Now, why am I replicating it to all vertices? Again, the only reason for it is just to eliminate possible mistakes thus far. In the future, what we would like to do is make it per fragment, and then we will not be specifying it here anymore. It will be specified in a separate sideband array. For the moment, though, we're not going to do that, right? Okay. So what we're going to do here is we're going to hard code these. In the future, we will probably, I don't know, oh, that's not light color. It's light count. Okay. So we've got the light count in here. And what we want to do is say, from now on, we're just going to have the light count is always 4, right? And the light index is always going to be whatever our quad index was, right? So we know that we have a quad index, which is the vert count. In fact, we know that that's what it is, right? So we know that like our vert index is this. So we can just use that because it's already going up by 4, right? So that should allow us to do what we wanted to do, which is just striate these correctly. What did I actually call this? Is it first light index? Light offset. Surprise, it's light index now. All right. What did I call it in the fragment shader? I called it light offset. It's not light offset, it's light index. It's an actual index. All right. Lovely. Now, when we run this, we should not see any real difference here. Excuse me. Ooh. Did I mess up something when I changed that? Ah, I did. My bad. This was supposed to be replaced as well and wasn't. Lovely. So now we have a vertex stream that properly has 4 spaces reserved in the texture for it, right? Because I have properly placed, each one of them has 4 spaces. We say that there are 4 of them. So now our shader should be able to read that. We just now have 2 steps we have to do. 1, we have to put something in there, right? And we'll do that step second. The other thing we have to do is actually bind the vertex, these additional vertex values, right? So what you can see here is when we do, for example, this binding down here, right? You can see we're not actually binding any vertex information. Up here in the use program begin, you can see we've got the is valid array stuff. That is what we actually now need to do. So we're gonna have to do a thing that's like is valid array, light offset, is valid array light count. So those 2 things we now have to just grab, and they are both the same kind, right? They're unsigned short. There's only one of them in each case. Since they're pairs, I guess now that I think about it, I probably should just do them as 1. But I don't know if you can do that. I don't know what you call that. It's because there's a vec2. I don't know in the shader if there's a unsigned short 2. So I'm just going to leave it as 2 separate arrays for now, but that's worth noting. So I don't know. We don't want them normalized. That's what this parameter is, right? We want them to remain unnormalized. Right? Yeah. So we don't want them normalized. Like the GL unsigned byte, for example, gets normalized. So it takes a 0 to 255 range and maps it to 0 to 1. We don't want to do that. For some reason I did it again. I really want to call this light offset in some places and light index in others. We don't know why. So once we've got that, We should be pretty good to go here. That should all be sent down, but we need obviously somewhere that this gets recorded. Like so. We need to disable it. Probably should have put these in an array. I didn't put array on the end of these for reasons that nobody knows. We don't know why. Probably because I don't really care about them. Because like I said, these should probably be sent down as a single array, and it probably should be sent down only to the fragment shader, but we don't really know how to do that just yet. All right, so we'll disable those two and enable them as necessary. When we do use program begin, that will automatically happen. So I think that's all good. So really then what we have to do is make sure that the part where we actually get the locations, so in this OpenGL create program, for example, right here we need light, vert light index, vert light count, and those should just give us back the binding location. So now, in theory anyway, we are sending down those values. We have not put... Well, actually, no. So now, in theory anyway, we know we have a bug. Because the lighting, when I run the lighting, it will write values in there. They'll be like, you know, who knows what the values will be, but they'll be in there. So... we do sort of know that that's not quite right yet, because we must be binding something incorrectly, or we would be seeing some of that information coming through, I think. I don't want to 100% count on that just yet, so I am going to go ahead and set the lighting stuff anyway, just to be safe. But I'm pretty sure I must have not quite gotten everything set up properly there, because I think we should have seen that come through, and we didn't. Right? You know what though? This right here is the wrong name. That's one of it. So here in the ZBias program, if we want this would have to be vert light index and vert light count, and we didn't set them either. So we have to finish this part of it. As a pass-through. Oh my. Something very bad has happened. But I don't know what. It's just getting slower and slower and slower. That's a very curious result. Wouldn't you say? So why is it doing that? That's as if the frag light count values were going up and up and up and up or something. Right? Something strange is happening there. Can't say I see immediately what it is. It could be that we're not unbinding something that we bound. would be another thing that could cause something like that. Like if we're constantly adding more and more vertex buffers, right? So if, for example, so here's where we enable our vertex array, attrib arrays here, right? The light index and the light count. We enable both of these and give them pointers. And so maybe I didn't actually do this right here. Although it sure looks like I did. Right? It looks like they both get disabled. And plus that couldn't really have done it, I don't think. So let me flip back over here real quick. I just want to make sure what we're passing down. Do we ever pass anything else down? I think everything goes through push quad. Right? Yeah. So looking at this, the light index goes up. The light count doesn't. Just one thing I should change or verify. Light index is light index and light count is light count, correct? Because that would also be potentially bad. Yeah. So I'm not sure what's happening there. That's very interesting, right? You see what's happening there, right? Starts out fast, ends up getting slower and slower and slower and slower. Now, that could just be because more stuff is on the screen, but I can't imagine why. Let me just do a quick check here just to see. Let's suppose we don't do this, right? Like we don't do this call. So instead we just do like so it's definitely the while loop that's the problem here, right? Oh, I know what the problem is. We were still fetching the next light index. We don't want that. We just want to loop, oops, we just want to loop through. That could easily be it. So let's double check that. Nope, still wrong. Because the light index was getting modified there, so I feel like that could have been bad. Although, well, no, because it would still only do however many it was supposed to do in count. So even though it was reading from that light index, that shouldn't really have been a problem, right? All right, well, so let's set light count equal to 4, which is what we think it should be. And let's try to verify that it actually works okay if it's 4. All right. So it looks like what we're having is a problem that the light count is not properly getting set to 4 always, I guess. Because in theory, we should never have a vertex whose light count is not 4. Right? I mean, you can look at this and see vert 0 light count equals light count, vert 1 light count equals light count, vert 2 light count equals light count, vert 3 light count equals light count. They're all set to light count, and light count is equal to 4. So I'm not sure why it would ever not be equal to 4, but guess what? It isn't. The question is, how is it getting set to something other than 4? Is there anything that draws non-quads? I thought everything drew quads. At the end of the day, I thought everything went through that pipe. And I don't really mean that. I don't mean does everything draw quads. What I mean is, does everything draw actual... does everything go through the actual draw quad call? So yeah, I'm not too sure about that. Let's maybe try to take advantage of the fact that we, in theory, can run graphics debugging here, and let's see what happens. Ooh, excuse me. We only have about 20 minutes left or so, but let's just take a look and see if we can get that part working, because that way we can start tomorrow with a working way of sending these down in a working order. So I forget the magic dance I had to do to get this thing to work before. I'm just going to try to do start graphics debugging. Hopefully that'll work. And now I'll just go ahead and do pause and capture frame. I think that works. Yeah. So here we have paused and captured a frame. So if we go into our vertex attributes now, we should be able to see what we're actually getting. So, here's a pass right here, for example. We should be able to see which elements are being set and all that good stuff. All right. So unfortunately, I guess we have to use the buggy version because you can see it has optimized out our other short. I guess one thing we could do to prevent disaster let's try that. Start graphics debugging. So that's still nice and zippy, so that is working. End site, pause and capture frame. And now hopefully we have 2. No, we still don't. Well, maybe that explains it. if the problem is that we're not binding that array. Because we should see 2 unsigned short arrays here, but we're not. So let's figure out why. All right, maybe I just have a spelling error. And that would be simple. So in here, the name of this input oh, great. Well, that was easy. So I guess we did have a spelling error. That's probably it. That was just a typo. But it was a bad typo. Thank you to the graphics debugger for working. And there we go. All right. So I still would have expected to see some data in there. So I'm not sure everything's working quite right yet. But at least we got rid of that. That was definitely a bad typo, so that's no good. So let's finish by stuffing some things into that array. And then we will go ahead and play around with things tomorrow in actually sort of setting up the lighting samples. So what I want to do, again, is just push some structured art down here. So I'm going to go into the render group. Let me put it in one that doesn't have my head in front of it. So when we do our output lighting textures now, we don't really need to do a lot of the stuff that we were doing before. So we'll have to kind of rewrite these routines since we don't need the voxel stuff. Like none of this stuff is necessary, right? This stuff is all kind of old news. And so what we got to do now is kind of think about this a little bit differently. But for now, let's do this the simple way. So in here where we've got like pack index and that stuff, and we're sort of creating linked lists, we're gonna nuke that out, right? That's not gonna happen anymore. And in fact, maybe I'll just leave this in again because we don't really know what we're gonna do here. This is all experimental code, so I don't want to delete a bunch of code that maybe then I decide I actually need again. So let's start with this and delete it in a separate pass here so we can kind of keep the old one around. So we don't need any of this voxel stuff, right? The voxel stuff goes away. And so we don't need any of the packing stuff either, like the lookup or the next pointers. Those are no longer relevant to us and we can ignore them completely. So then what we have here in our lighting element is when we pull it out, what we want to do is basically have the packing index specified in the lighting element. I think that's probably what we want to do. So what we want to do is say, all right, the place that we're going to pack this thing, that pack index should probably be directly in the lighting element itself. So where we're going to put this lighting sample back, that's going to just be directly specified by the lighting element, right? So everything we write from here on out is going to go there. No voxel involved. I'm going to compile that. It should complain because there won't be a pack index. But we're going to add one. Now, the destination stuff here, this stuff is all garbage now, so this is not relevant. I guess the right way to do this to leave that probably in there and getting set. Let me just go ahead and create false versions of these. Let's see what else we got. Celdim and inverse celdim. And so now all we should have to do is just augment that lighting element, right, to specify where it should get packed, like where into the lighting array it needs to get packed. So here I'll just have the pack index sitting at the bottom. We're able to compile now, but we're not actually setting it anywhere. So when we do extract, oops. Reflectors from quads, and we come down through here. Whatever we create in terms of things that we want to pack in here, we're going to have to set each lighting element's pack index to something sane, right? Now it occurs to me that actually we can overwrite the packing values here, so we could actually keep pretty much exactly what we have. We really don't need to change this at all. So what we could probably do is say, all right, you know what, forget about that. Let's say the packing index here is equal to 0. Let's say that every time we create a new element, we set its packing index to whatever the packing index actually is. And here we'll do an L count, like an element count. We don't, I guess we know what it is. It's just subcount, the two subcounts times each other, right? But then what we can do is say, all right, well, now that we know, like, we're grabbing out these vertices here, right? Vert 0, 1, 2, right? What we can do is say vert 0, light index equals vert 1, light index equals vert 2, light index equals vert 3, light index equals pack index, right? Vert 0 light count. Wouldn't it be great if like C could actually do stuff like this? You know? C++ is such a piece of junk. It's hilarious how they've like never added anything that's any good ever. And there's so much stuff that's like so obvious. They're just like, yeah. We'd rather just dink around with stupid changes designed to make lousy programmers make less mistakes. It's like, all right. Thanks for nothing, guys. All right, so x subcount times y subcount. So there I will basically say, okay, let's just actually have gotta set this first. There we go. Let's just actually have this thing, however much it subdivides, we'll use that number of lighting samples for this particular surface. So that will actually be accurate, right? At least I think it should be. Yeah, but these do clip out. That's true. All right. So I don't think this will work, though, because, like I said before, even though now, in theory, we're packing the lights into the right locations, it seemed like we weren't actually grabbing them out properly before. So something's a little bit busted in that gather, so we don't really know. I'm going to stuff structured light down ahead of time, I think, like I was saying, in order to make sure things work. But we also need to go take a look and find out why we're getting this sort of never actually able to grab the colors. And it's probably just something that I messed up in the OpenGL setup, because it's really easy to do mess ups with your OpenGL setup. So anyway, like looking through here, I just want to make sure this is sane. I've got the sumLight call with what's being returned from that just gets directly modulated. Looking at the results, it's doing texel fetches the way that we normally would, and that seems okay. So yeah, everything's fetching off of that light eye, which seems okay. That seems like what I would expect. So I think Let me just go ahead and see if this is working at all, though. I just want to... I just want to bump a red channel there to make sure. Yeah, I didn't know if there was like something else that was potentially going on there. I wasn't sure, so I just want to make sure that we can actually. So we know that our summations, if something properly summed into that light, we would see the result there. There's not like some squinky thing happening that would, you know, knock that out. So we have one of two things potentially happening. We don't know which. Either the actual packing somehow is now really wrong and the light is not getting put into the light array in a sane fashion, or this light sampling, where we're sampling the light index here, we're somehow getting the value, the actual light index value, is not properly pointing to one of these arrays in the right way. Like it's, you know, it's indexing off of the wrong thing somehow. We're just not sure how. So that I'm just not sure what the best way to go about looking at is. Probably see if we can capture a frame and take a look to see what these values are likely to be. We can't say for sure what they are because we can't step into the shader. I found out why that was, by the way. I think James Widman was the person who wrote in and mentioned it. Which is that the reason I can debug shaders on my dev machine and not this machine is actually just because they haven't supported shader debugging on the 1080s. That graphics card doesn't support them yet. So the fact that I'm using an older graphics card in my main dev machine is actually a plus, because I don't remember what that thing is. It might be a 600 series, it might be an 800 series. I don't remember. It's an NVIDIA card. Running Insight on that card, you can step through the shaders. Running Insight on this card, you can't. So what are you going to do? So we can't actually step through and see specifically what might be wrong there, but we can look at those arrays, right? That will be inspectable. And so let's just go on a little bit of a fishing expedition here, because rather than start fiddling with it completely blind, why not use the tool we do have to just eliminate some parts of the problem from suspicion, right? So what I'm going to do here is I'm going to do a pause and capture frame and just look to see if I can at least verify that those arrays... Oh, well, you know what? We got to actually run the lighting, or there won't be anything in those arrays. All right. So one more time. Okay. So if I run the lighting solution, unrun the lighting solution, well, it's still running, just switch back to regular mode. This should now have sent something down to those arrays, and we can now look and see whether it actually did and what those, if those values are coherent or if they're not, right? So here's the vertex attributes, and we can read across and see the buffers that correspond to them. So buffers 4 and 5 are correctly set to non-normalized. And they are the two values that should have our light counts and our light indices. So what we should see is one of these should just have a bunch of count values in it, and one of them, I guess we need to set this to 16-bit integer unsigned. Did that show us? So that's not good at all. If that's actually right, that's not good. Oh, okay, but that's the whole buffer. So, okay, ignore that for 1 second. That's the whole buffer there. I don't know if it lets us see it strided, so that might be harder to deal with. So here's the entire buffer, right? It's we're gonna have to sort of pick and choose through it to figure out where our actual unsigned int values are. But we do know the size of the thing, so we should be able to take our vertex layout and see it correctly, right? I don't know if there's any nice tool in here that really lets us do it. Probably there isn't. It would be nice, though, if there was. Because it should be able to do that. Maybe it can if I go to the vertex shader. Maybe it could do that so we don't have to slice it out. I'm not sure. Yeah, I don't know. There might be a smarter way to do this than what I'm about to do, so I apologize for that. I am not the kind of person who spends all their day in graphics coding. So I'm just going to have to do this the hard way for now. I'm going to set it to 16-bit unsigned, which is what we want to see. But remember, we're looking at the buffer that actually represents all of our vertex data. So what that means is that all we're really seeing in that memory view is we're just seeing these textured vertices stacked up. So if you take a look at how many there are here, right? There's 32-bit values at the front. There's 4 plus 3 plus 2 of them, right? Plus these, it's 11. So we know there's 12 32-bit values in here, right? 12 32-bit values is 24. I don't know if we can set... No, we can't. So 3 rows of this is how many there are for each of our vertices. You can see that there's nonsense values here. That's their floating point values, right? So what we see here is 0, 4, 0, 4, 0, 4, 0, 4, 4, 4, 4, 4, 4, 4, 4, 4, right? 8, 4, 8, 4, 8, 4, 8, 4, 12, 4, 12, 4, 12, 4. That's exactly what we would expect. Everything has 4. We should be able to get to some that have more than 4. Those would be ones that are subdivided, right? So we should be able to find some in here that are subdivided, I would hope. Although I'm not really seeing it. Oh. Well, you know what? Unless we call that every frame, that wouldn't work either. So, yeah, I guess that's true. We have to actually do that reassignment a little more carefully. We have to do... This is not necessarily related to the problem we were tracking, but I just realized we've got one other problem. Since we don't run the lighting solution every frame, because we're not trying to do the full GPU accelerated frame by frame one, and we just want to be able to it to be as slow as we need it to be to test. This extract can't really do the remap. I kind of got overzealous there. Extract can't do the remap because it has to be run only when you hit the F1 key. So we can't actually have this correspond properly. So when we do that F1 there, and we do output lighting quads, this would actually have to reconstruct that information, right? And there's really nothing we can do about that, unfortunately. So we may have to kind of step up our game here a little bit. Or just leave things the way that they were without subdividing. Right? So we can't really write into that. We have to use what we've got. And so for now, we would have to do something where we would say, okay, the x sub count and the y sub count, they pretty much have to be fixed at 2, because we know we only have 4 elements to write into for every quad that comes down, right? So the pack index here, in fact, has to be exactly 0, 1, 2, 3, 4. That's what has to happen. And the pack index has to come from the vertex, right? So we have to do pack index equals vert 0 light index. We have to target that. We don't have a choice. And we can only do 4. That's what we have to do right now. And we can improve that going forwards when we actually have a more streamlined light situation. But that's actually what we have to do. So that's the only fair way to do it. And now we will actually have a lighting solution that would line up properly in theory. Okay, so that's fine. Before I go to Q&A, I do want to finish what I was doing, though, which is to run the graphics debugger and just see what's in those other buffers, the lighting buffers themselves. So here, if I was to capture a frame, I should be able to look at what the lighting buffers are that the fragment shader is sampling from. So that I would like to take a look at. Here is the, there it is. Here is actually, you know what? No, that's not it. That's the frame buffer, which I don't care about. I actually want the fragment shader, which I have to move to a different one for. Here we go. So here's the C sampler and the D sampler, the PNext sampler, etc., etc. I'm just going to look and see whether these have anything in them that makes sense, right? I mean, they should, in theory, but I don't really know. So, oops, I got to remember which one I clicked on since it doesn't really give me any information. So let's take a look at the C sampler. That should be the color values, right? All right. So, I mean, there's plenty of color values in here. There's definitely a lot of blacks, but there's definitely a lot of colors. So, I don't know. That's a little bit hard to say, but there's certainly... I mean, you certainly expect to see something, right? So, I'm a little confused as to why we're not able to see anything at all. That seems a bit odd to me. I would like to just verify again that the vertex shader is getting that information, but I think that it is. I mean, based on what we looked at before, it certainly seemed like it was. So that's a little bit odd. Does the fragment shader list an input? How come like this? I don't really want uniforms. I just want the... Here it is. This is what I wanted. Can you show me this? I just want to look at this. Why does it say GL unsigned int? I guess that's because that's what it comes through as. I wonder if that means me defining it as a short is wrong and I need to define it as an integer instead. Because I told it it was an unsigned short, but it says it's an unsigned int, and I don't know exactly how that fetch is going to be working. I feel like the vertex specification does correctly say that it's an unsigned short, so I feel like the fetch should fetch it as a short and turn it into an int, but I don't know if that means that it shouldn't be specified that way in the actual shader itself. You know what I'm saying? Like, I'm wondering if that means that this is not actually... It should be just unsigned int here. You know, or just plain int. We don't need it to be unsigned for any particular reason, obviously. I don't know. That doesn't seem likely, but if that's what it actually thinks the actual input is, I wonder if that implies we have to set it this way. Like maybe it just doesn't deal with shorts. Well, that definitely changed things. Right? I mean, before we were kind of crashing out there, and now all of a sudden we're getting a kind of a freeze in there. Right? And all I did was change it to an unsigned int in each of these cases. That's it. I didn't touch anything else. Right? So I'm interested to see, is there a way we can get some is there a way we can get some debug info on that? Nah. Doesn't look like... It's never put anything into the log that really tells us anything. So let's play with that a little bit. When we actually go in here to sum length, and we get our frag light index out here and our frag light count, I'm wondering if our frag light count is completely bogus now somehow. I'm going to go ahead and do the same trick we did before. First, we'll try this. So it is that light count value is a bogus value at the moment. It would seem. Right? So I'm not sure where we're getting those errant values in there. But somehow we're not set up to read this properly. We just don't know how. So what would be the best way, since we can't see what these values are, when we look at what they should be in the buffer, they look correct, right? It was like 0, 4, 4, 4, 12, 4, 16, 4, those sorts of values, right? Which was exactly what we thought they should be. And the indices are also correct. So we don't really know why we're getting weird results in here. But for now, I'll leave this in, and we'll go to the Q&A. We'll have to revisit tomorrow. All right. Okay, question time. What texture file type will you use? We actually at the moment just have our own pack file. We probably will just use a basic, like a very simple zip to zip them or something like this. We don't need to do texture compression because we don't have enough textures that would require it. And if you use hardware texture compression, your quality suffers, and I don't want that. So because we don't need it, we won't use like DXT or anything like that, DXTC or anything like that, because that just makes our quality lower for no benefit. We don't need the extra bandwidth and we don't need the extra space. So someone asked if we could set. Oh, it's a soft. He asked if we could set the font larger, and that does look like we can. I don't know what font we actually want though. I think I use Liberation Mono or Droid Sans Mono. I think I use Droid Sans Mono now. Oh, I forgot. Right. Windows can't install a font from a substituted drive because, you know, they're just that good at their job. There we go. So now we should be able to pick Droid Sans Mono in here. Or not. Can we not do a fixed font? I guess I just had to reboot the program. So now it should be roughly the same font as in the editor. In what structure do you organize world objects? We use a sparse grid. It's basically like a, how should I put it? We use a hash table of 3D locations, and we truncate everything to a sort of coarse 3D location and store it into sort of a block. And we store all the entities and their actual locations inside that block. Okay. I think you missed an equal sign in one of the shaders when defining im something 111. That wouldn't have been a shader, would it? You talking about this? You are correct, I did. I don't think that'll help us, but thanks for the catch. Oh. Goodbye, MSDev. Just used any comments on using SQLite as a file format for a game. I guess I would say I don't have any objections to using SQLite as the file format for a game as long as you're not performance critical. I would not use SQLite for anything that was performance critical. But if it's not performance critical, like you're not storing very much data in it, then it should be okay. Silaresco. Man, isn't it weird how OpenGL is with how you have to interface with it to do things like you send it a string and then you put two shaders together to make a program? It's like esoteric and stuff. Yeah, it's awful. Modern computers have two chips in them of equal complexity, more or less. The GPU and the CPU. The CPU has a real compiler that you can edit with real language with a real debugger and a real memory system, and the GPU has none of those things. So you can't even just code GPU code into your regular code and have it go through the same linker and output actual code into an executable that gets bound. Like there isn't even a executable file format for these things that works together, right? It's this ugly polyp off to the side. It's horrible, right? It's as if you couldn't have two C files have the same variable in them. They had to like create a string that named that variable and then manually called a function to look it up, right? It's just nuts. The whole point of the compiler is it does the mapping of strings to offsets for you. That's what the compiler does, right? It's one of the main things it does. And we just don't even have that yet. And it's crazy. We've been programming these GPUs for like, I don't even know, almost 20 years now, I want to say, and we haven't gotten it. It's crazy. Merkelba, what percentage of the way through the game do you think you are? I have no idea. We do a lot of educational stuff on the stream that isn't necessarily about trying to finish the game, so it's hard to say. Curious question, why F32 has a lowercase f while F32 Max is a uppercase f? Because I use lowercase for types and uppercase for values. In what video index do you start with discussion about using a three-dimensional voxel for lighting? I don't know. We've done a bunch of streams on lighting because it's a tough problem and I'm just kind of like developing a new solution. I'm not just implementing an existing solution. So we didn't start right off with a voxel. So I don't remember. It'd be, 15 streams back, 15 episodes back, maybe somewhere in there. Could we use the normalized light count index to 1 and use them to build a color? Maybe in this way we can see what value we get. Yeah, we could try to just use those as color values and see what we see. That's not a bad idea. I don't know. So if we were to do that, right, what we could do is say, instead of calling some light at all, which is down here, and we could, just directly write it out the color. We could say that the light value equals the frag light count, and the green value equals the frag light offset. Since we know this value should be pretty small, what we could do is say like, it's whatever this is divided by, 16. So we just have a red channel that was like a quarter hot when there were 4, which is what we should see most of the time. For the frag light offset, we'd have to divide it by a much higher number, but that should give us 2 channels that, show us roughly what's going on there. So, what? Oh. Of course it doesn't. Oops. There we go. I guess I don't need to cast those. I mean, they are floating point values already. And it doesn't like the F suffix as well, so we've got to get rid of those. Undefined variable frag light offset. Of course, I always want to call it light offset instead of light index. Don't ask me why. So, I mean, this is what we thought, right? Which is that we're getting completely bogus values in there. Uh, the question is just why, you know? We looked at the values in the buffer and they looked right. Let me see what happens if I change it back to shorts. Just curious. I assume it won't make a difference, but I don't really know. So we're just not getting the values that we should be getting based on the buffer. We must have like the offset wrong or something. Or like the vertex pointer is off somehow, you know? But basically that's, I mean, it's a good suggestion, right? It totally confirms what we thought was happening. But it doesn't really help us figure out why. Like I just don't know why we're getting those bogus values in there. I mean, these look like the right thing. I mean, I guess, yeah, I don't know. I really just don't know why we're getting that, so we're gonna have to figure out. Miss Fielder, have you considered cascaded voxels, as in cascaded voxel cone tracing, as a data structure for Handmade Hero lighting samples? Not for the samples, but we will when we eventually go to do the ray tracing accelerated. We probably will do something multi-res. Have you ever seen the source code of a GPU driver? Not one of the not NVIDIA's or AMD's. I have seen the source code of the Intel drivers, at least one of them, because I worked on it. The one that was going to be for Larrabee. So I have seen that code. Oh, you're right. I did not run the lighting. Well, no, but we don't need to run the lighting calculation because the lighting calculation isn't required. These values are set at push time. They're supposed to be set to 0, 4, 8, right? So they're always set. And we're just not getting those values. We don't need to run the lighting calculation because those values are actually just getting set immediately. They get set in push quad, and they should just look like monotonically increasing values, but they don't. So we're getting something is weird about the way we're pulling these values in is not good. But I'm not sure, because we should see a range of values and we're not. Alex, so what kind of work did you do on the Intel driver? So I didn't do much. I was just contracting, and it was the Intel driver for when they were going to make a x86 based graphics part. It was the Larrabee project, which eventually became the like Xeon Phi. You can buy them now, but they're not used for graphics. They were trying to make those work for like DirectX rendering and stuff like that. And most of the stuff I did was I only did like a few months of work on it, but I did stuff to analyze like state transitions and some stuff to play with how shaders were compiled onto it. Um, but that's really it. And they did not end up shipping those cards for that purpose. So it was purely like research oriented. Black Pawn C, what kinds of things do you most enjoy coding and what things the least? So the only things I don't really enjoy coding are things where I don't have access to what's actually happening. So you could say like this kind of GPU coding is something I enjoy least. And the reason is because I'm not really programming a computer, I'm programming somebody's idea of how I should program a computer. Same reason I don't like programming C++, high-level constructs. Same reason I don't like programming operating system API calls. I like programming, something that's well specified and complete. I don't really like programming on top of like hacky nonsense. So, I don't like using graphics APIs and I don't like using operating system APIs because I typically disagree with how they've been designed and I know that they're not doing what I probably think they should be doing in terms of how I want them to talk to the hardware that is underneath, right? So that's the thing I like least. What I like most is when I have the control to do what I want to do. So when I'm just in my own code, that's much more satisfying. And when I'm using a language that's sane. If you were coding for a console, would you be able to debug the graphics part of it? Do they give you hardware info down to implementation details? Some do, some don't. It depends on the console. But yeah, almost universally, you have a lot more. So, for example, you may not necessarily have great debugging, but you will have a lot more information about what the chip does, and you will have a lot more opportunities to, program it the way you think and create an API that makes sense and works well. All right, that's the end of the queue. So tomorrow we will pick up where we left off and try to figure out why we're getting kind of wrong values ingested into the shader there. There's probably something happening, but we'll see. Graga, do you normally comment more than you do for the stream? Your code is clean to look at, but it feels like a big company, they would eat you up for not documenting a lot more. Well, no, I actually don't comment more than this. And I would say that in general, that's why I don't work at big companies. I think big companies are basically like kind of living examples of how to take a problem that should take like 1 or 2 programmers to solve and take 500 programmers to solve it. I mean, that's what they do. I wouldn't work at a big company unless I had to. If I needed the money, I couldn't get a job, and I need the money, then I'll do whatever. But that's why I don't work at them. I think they don't have good processes, and I think their output speaks for itself. I think I can't think of a large company whose software is shipped in a routine manner at a high quality level with good features and sane design. I can't think of a single one. On the other hand, I can think of some small companies that do. So, yeah, I think you would. I think at a big company, after, I don't know how many episodes of Handmade Hero we've done here, I think if you took the equivalent amount of time it's taken us to do this stuff on Handmade Hero, I think at a big company, even if they didn't have to be explaining it on stream, they probably would have gotten almost to the point where they could maybe show a bitmap on the screen or something, because they would have had so many code reviews and meetings and everything else related to every last little thing they did, they would never have been able to ever do hardly any of the stuff that we ended up doing. And they certainly wouldn't have been able to do all the experiments that we've done or all of the learning digressions we've done and so on. They're just incredibly slow. They get incredibly low output per programmer at big companies. It's nuts. I mean, I think Twitter is a classic example. I would challenge you to try and figure out how Twitter has, I don't even know how many engineers they have. They have something like over 1,000 engineers. I mean, I just don't, I can't even in my brain imagine what they're all doing. I don't know. But the answer is usually that they're all really not doing anything. They're mostly spending their time doing stuff like adhering to weird coding standards or arguing with their manager about something or being in a meeting being dismayed or spending a lot of time in code reviews, reviewing code that will get deleted the week after. And it just sucks up all your productivity so that you need 10 times, 100 times the number of engineers you should need to do something. I don't necessarily blame them for this because I don't know how you scale up if you really want that many engineers working. I don't know how you make them all efficient. You probably can't, or maybe you need much more advanced stuff than we have now. But at the same time, that's why I would never work there, especially not on something small. Like, it's weird, like things like Twitter, they ship an incredibly small product. That's like a 4 or 5 person team, I would think, could ship Twitter, right? But it takes them 2,000 engineers, you know? And I'm just like, I don't know. Yeah, I mean, why? And how come you haven't asked the question why? Like, how come you don't have a good answer as to why, right? So I don't know. Will feel, I work for a large company, but in a very researchy area. Honestly, I feel like I have the best of both worlds. And yeah, you might be able to. So like one of the nice things about if you can work in a pocket of a large company that's sane, like Microsoft Research, at least for a while. I don't know if it's the same these days, but you know, you could just be doing research on your own thing, publishing papers, and no one's bothering you, right? You get a paycheck and a nice office, and you can go explore important problems, and you probably aren't bothered a ton. And they're probably not forcing you to code review stuff, and they're probably not forcing you to do this or that, right? And so, you know, that's a good option. Halst80 said, I work at Frostbite, and I think you would fit right in. Yeah, like I said, you know, big company is hard to specify. Like I said, I can think of small teams that do good work. And there might be some medium-sized teams that do big work. I wouldn't consider the Frostbite team to be that large, to be honest with you, compared to what I assume people mean by big company. And there are obviously teams, like, I don't think the Bungie team goes nuts with code reviews, for example, right? So I think there's definitely like 50 to 100 size programming teams, usually in the game industry, but not always. Like the team that does Reaper, the audio editor, for example, I bet they don't spend a lot of time doing stupid stuff like, you know, commenting a bunch of code, and then that way the comments will be wrong the next day when you change something in the algorithm, right? So yeah. And for all I know, there might be some large company somewhere that does have 1,000 engineers and actually somehow maintains sanity and doesn't force them to do a bunch of stupid stuff. I don't know. But a lot of large companies don't. A lot of large companies are very bad at that. Right? I can speak from a little bit of insider information, I suppose. For a company like Microsoft, for example, if you're on, like I was saying, Microsoft Research might be the same place. Microsoft Windows, for example, is completely, I mean, forget it. I've seen what goes on in the development of stuff on there, and there will never be another, you know, there will never be a positive development in Microsoft Windows. It's over. because the way they do development doesn't even allow people to be effective, even if they were a good programmer, wouldn't matter, right? And so it's definitely very risky and very possible for your company to develop these methodologies that it thinks are good ideas, but that actually mean that you will just never be productive again, right? And then your code will always be big and bloated and slow and bad, and you will have trouble adding features, and the features you do add will be lousy, right? So, yeah. So anyway, so I stay away from big companies for this reason. But again, yeah, that doesn't really mean that all big companies are awful to work at or anything. And it also doesn't mean that you can't take a company, even one, like I said, that I know is really bad in some product areas and you would never want to work there. You still might find divisions or regions inside that company that are nice to work for, right? That happens. So it depends. You know, if someone says you work for Microsoft, it could mean a lot of things. It might mean that you're absolutely miserable and every day is horrible because you're working on Microsoft Windows or something, or it might mean that you're having a great time researching like cool speech recognition stuff in some corner of the Microsoft research building and nobody bothers you, and you got plenty of smart people around to talk to, you know. So like when a company gets that big, another sort of corollary of that is there are going to be very big differences potentially in what it feels like to work at different sections of the company. And I feel like the person who mentioned DICE, that's probably could be true at EA as well. It could be that DICE is very nice to work at, but other parts of EA aren't, right? So I think that's just the case. Having worked at a few large companies, I found the need for commenting code arises from disproportionate skill levels among the developers. Less skilled or less interested engineers tend to complain about uncommented code. So my problem with comments is that it's almost impossible to keep them accurate. That's the problem. I don't really have a problem with commented code if the code is finished and no one's ever going to touch it again. Then commenting it is kind of like just writing the docs for the code, right? And that's fine. But if you know a piece of code isn't done, it should never be commented with anything other than notes about what you still need to do to it or pitfalls that you need to watch out for that you think you might forget. That's the only thing that should be in the comments. But commenting the code, like what the code does, is not acceptable to me because I've never seen it stay in sync. The amount of effort you have to put in to keep the comments in sync is way more than the effort you're saving on the other engineer's part who has to come in and read it. So the only time I think commenting is valid is in those cases, right? Either you're finished this code, it's like a library, right? And it's like, the code is done, I'm not changing it at all for quite some time, except to fix bugs that would be in contrast to the comments, right? That would be violating the comments. Then, okay, here is some documentation that says how the code works and how you should use it. Yes, right? But on the other hand, if it's code that's under active development, no comments. Like the comments should only be notes about what you've learned in development or something like that, because those will always be correct if they're just saying something that happened, right? So, you know, I think to-dos is mostly what should be in here, and notes like, you know, like this are fine, which just say why I did something in case I forgot or whatever, fine. But something that says like, here's how this piece of code works, always bad if the code isn't done because it will just rot and you'll forget to update the comment, you know? And that's the problem. So, you know, I mean, one of the main things I shipped was the animation library for RAD. And you might say that was commented very extensively because it had documentation that shipped with it, right? And I kept that documentation up to date. By when I finished something, I would change the documentation in like a separate pass, and then that would ship out to customers, right? Very important, very necessary. But commenting code as you're developing it just doesn't make sense. It's a real waste of time. And I really feel like people who think you should comment code while you're in the process of developing it, I don't think they know what they're talking about. I think that's something they're saying that they haven't really tested and haven't really measured, which is unfortunately what a lot of people, when they say things like that, they haven't really measured it, right? All right, that's about it. I'm gonna wind it down. Alrighty, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along with the series, as always, you can pre-order the game on handmadehero.org, and it comes with a source code so you can play around with it yourself. You could, for example, find the lightning bug that we're going to have to find tomorrow. You could find it before me. It would be great practice for you. You don't know the answer already, and it would give you some practice working with GPU code, which can be kind of tricky to work with because you can't do things like step through it. So that might be a good exercise for tonight for those of you who are looking for some homework. Anyway, and I will try to upload this immediately. So I will upload it immediately after this so you guys can debug it. Anyway, we also have a forum site you can go to if you want to ask questions. We have a new non-Patreon contribution page, so you don't have to use Patreon anymore. We got rid of it. It just goes through our own Sendowl backend stuff now. So it should be all nice and clean. No weird changes coming down the pipe or anything. And it now has yearly contribution options to try and help people making small contributions to not have to worry about the credit card fees. So you can pledge a larger amount less frequently instead of a smaller amount more frequently, and help to get rid of some of those fees that were the bane of the Patreon problem. We also have a schedule about that says when we're going to be live in case you want to catch the stream live. We also have an episode guide, which should be updated shortly. I know it's missing a few episodes on there. Apparently they had some problems integrating it with, they did some moves to the server over at Handmade Network. Not something I have a lot of insight into, but they are dealing with it right now, and so hopefully the episode guide will be up to date. The annotations have been done. Miblo has been on top of it. It's just they can't get pushed to the server for some reason. So that'll get sorted out soon, and then the episode guide will be back up to date. That's about it for today. I'll be back here tomorrow to find what's going on with why we can't send those lightning values down to the GPU correctly. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.